For this video, we're going to graph the exponential function y equals 3 to the x power. So you notice that your x is in the exponent position, making it an exponential function. We can determine if this is a growth or decay based on the base of the exponent of x. So you've got 3 to the x power, so that base of 3 tells us if that's a growth or decay. If that number is bigger than 1, then it's going to be a growth. So because we have 3, it's bigger than 1, that's a growth. The y-intercept, a really quick way to get a y-intercept is to plug a 0 in for the x. So you can do y equals 3 to the 0 power. Anything raised to the 0 power is 1, so your y-intercept will be 1. And then the growth factor is going to be that 3, that base that goes with your exponent of x. So the growth factor is 3. To graph this, we have a table of values where x's range from -2 to +2. So all you have to do is plug in the values for x. So first we'll do y equals 3 to the -2 power. And you can type that into your calculator. You're going to get a 0.1 repeating. And we can just go ahead and write in 0.1 repeating. Then go ahead and type in a -1, so y equals 3 to the -1 power. When you do that, you're going to get a 0.3 repeating. Plug in a 0 for the y. Well, that one we did already do for the y-intercept. That's 3 to the 0 power. Anything raised to the 0 power is 1. Let me scooch this up a little bit. All right, plug in a 1 for the x, so y equals 3 to the first power. 3 to the first power is 3. And then we have y equals 3 to the second power, and 3 to the second power will give us 9. So now we're ready to plot all these ordered pairs that we just came up with. So the first ordered pair we have -2 and then a 0.1 repeating. So that's pretty small. We're going to estimate that. Maybe I'll zoom in on the graph a little bit. So we have a -2, so we go from the origin 2 to the left, and then you're going to go up just barely a little bit for that 0.1 repeating. It's right above the x-axis. Then you have a -1, -1.3 repeating. So if we look at our graph, we're going to go from the origin 1 to the left, then up a third of the way for that 0.3 repeating. So that's going to be just a little bit above the 0.1 repeating. Then our ordered pair, the next one, the x was a 0, the y was a 1. So from the origin, the x is 0, so we're not going left or right at all, but we're going to go up one spot. So it's going to put us right there. And then our next ordered pair was 1, 3. So over from the origin, 1 to the right, up 3, puts us right there. And then the last one is probably going to go off my graph a little bit. It's over 2 and up 9. So if I go up 9, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be, I'll just estimate up there. So you can see the graph is taking this curved shape. That's what exponential functions will look like. This one is a growth, so we read the graphs from the left to the right. So from the left side, you can see that we hit the points, and it's going up for a growth. So that's an exponential growth. We go ahead and draw on our lines. It's going to be curved, and then when it comes down on this side, it's not going to cross the x-axis. It's just going to get closer and closer and closer to it. It kind of looks like it ends up sitting right above it. And then arrows on both ends. So again, your exponential growth from the left is going to come in on the left, and it's going to go up for the growth. Exponential growth graphs, they get faster in a hurry. That's why we went over 2 and we were already up 9. If we went over 3, we'd be up to, I think, a 27. So they get bigger in a hurry for sure. So that's how you would graph an exponential growth function.